Okay, so let's talk about polynomials. Polynomials are going to be our friends for the foreseeable future. So a polynomial is a collection of letters, variables, numbers, and operators. So terms, so first off, here are some examples of polynomials that you may have seen before. Scribble them up here. Examples of polynomials. 2x plus 1 is a polynomial. 3x squared minus 5y plus 9 is a polynomial. So we have letters, we have numbers, and we have operators, the pluses and the minuses. In addition, for polynomials, the exponents on our letters to be a polynomial, the exponents must be, how about this, non-negative integers. So non-negative is the politically correct, covering my bases way to say positive. So positive integers, counting numbers, including 0. Okay, so terms. Terms are the parts separated by the pluses and minuses. So in my first example, 2x plus 1, up there at the top, there are two terms. 2x is one term, positive 1 is the other term. My second example, there are three terms. 3x squared is one term, negative 5y is one term, positive 9 is one term. So the terms are the parts separated by the pluses and minuses. Monomial. So now these are just types of specific polynomials. And it's really just some vocabulary here, so we're all speaking the same language. So monomial is a polynomial with one term. Binomial, yes, I know. So I'm not going to write that whole thing. Right? Two terms. Exactly. Yeah, I know. Three terms. You got it. Okay, and after three terms, we don't give them any special name. They're just called generic polynomials. Okay? And in fact, all three of these can also just be called generic polynomial. Just sometimes I'll talk about trinomials, binomials, and monomials, and I'll need you to know what I'm talking about. Okay, so here's an example. 6, so try to read along, 6x squared minus 2x plus 1. So what are the terms? Exactly, so 6x squared is one of them, negative 2x is the other one, positive 1 is the third one. So there are three terms, so we would call this a trinomial, exactly. So coefficients are the numbers that multiply the variable. So in this particular example, the coefficients are 6. 6 multiplies a variable, and negative 2 is a coefficient. Degree talks about the power of the variable. Okay. So this term here, 6x to the second, its degree is 2. And for negative 2x, okay, it's not written there, so what's its degree? Right? There's a 1 that's understood. And now this can be kind of tricky. We have to think way back to our exponent properties. This term 1 also has a degree, even though it doesn't have a letter. That would be the same thing as 1 times x to the 0, right, which we would never write unless I was trying to be specifically tricky. But that 1 has a degree of 0. Now, if I ask, when I ask for the degree of the entire polynomial, it's the biggest one. So we can have degrees for individual terms, but I might also ask for the degree of the polynomial. So the highest power, largest number, is the degree of the polynomial. Okay, leading coefficient is the coefficient of the variable with the highest power. So in this particular example, the leading coefficient, okay, so the degree is 2, and the coefficient that goes along with that term is 6. Okay. The variable, right, is the letter. Who's the letter in this one? X. Right? X's are the variables that we have. And then lastly, the constant term. The constant term is the term that doesn't have any variables on it. Okay, the term without a variable. So for this particular one, the constant term is 1. Okay, so let's go ahead and do some more practicing. So I have, try to read it aloud with me, 7x to the 6th minus 3x. So describe the polynomial based on the number of terms. Binomial. Exactly. What is the degree of the polynomial? It's the highest power of x. 6. There's the highest power of the variable. Oh, and the variable is x. The only reason I keep doing x is because that's just what happens most often, and I'm not that creative. Your homework will mix it up a lot more than I do. Okay. And the leading coefficient. So the and I will abbreviate coefficient C-O-E-F-F. I will assume you don't have very many other words in your lexicon that start that way. So coefficient of the term that gave me the degree, 7. This particular example does not have a constant term, so I didn't ask for one. So one of the things we will do with polynomials is simplify. Again, simplify. So simplify polynomials by, so I've put it in quotes here because I will say this a lot, by combining like terms. Okay. So what is meant by like terms? So like terms, same variable, raised to the same power. And what we do when we combine them is we combine the coefficients. I often think of this as I'm going through the garden with my basket, and I only put like things in the basket. And when I've got all the things that are like in my basket, I go grab a different basket to go through again and get the next set of vegetables. Okay. So I have in here, what do I say? Simplify and write in descending order. Okay, well, let's see what we can do. So I start over here at the end, at the left side, and I take my basket through, and the first thing I come across are 3a to the fourths. So if I put the 3a to the fourths in my basket, the only other thing I can put in here are other a to the fourths. I can have a different number of them, but only a to the fourths go together. Okay, so 3a to the fourth plus 2x squared. Can't add that because it's different. X, different letter, different power. Can't add that to my 3a to the fourths. 7a to the fourth. That one I can because it has the same variable, same power. So 3a to the fourth plus 7a to the fourth gives me 10a to the fourths. And then I have plus 2a squared. Well, that has the same letter, but it has a different power, so I can't combine that one. So the 3a to the fourths is like 7a to the fourths. So I can add those together to get 10a to the fourth. It's just like counting. You just count the coefficients, and the variable part just stays the same. Sometimes if I have a big string of things, I'll put little, kind of like cross off to make sure I keep track of everybody. So I've gone all the way through the garden and taken up all of the a to the fourths, and now I've got my new basket. I'll do it in red. Go through my garden, and now I come up with a 2x squared. So I grab this 2x squared. Next thing that happens, though, is I lose one of the x squared. So 2x squared minus x squared. These guys can combine, same letter, same power. And I have a 2a to the second. Oh, a. Still a second, but it's an a, not an x, so that one can't combine. So 2x squared minus x squared is plus 1x squared. Okay, and you can write the one if you want, but you don't have to. Okay. And finally, so everything that's underlined has been picked up already. So the last thing I have is plus 2a squared. And that's all that we can do. Nobody else can combine because none of the other terms are like. They all have something that's different. So like terms, same letter, same power. They both have to be the same for us to add or subtract, which is essentially what combining like terms is. We're just adding and subtracting the coefficients. So that's one of the main things that we'll do with polynomials. The other key thing that we'll do is evaluate them. Okay, so polynomials typically have a variable or two, and what we'll want to do is evaluate them when values are given for the variables. So evaluate 2x minus 3y squared for x equals 3 and y equals 4. So what do you think we would do? It's pretty intuitive, and then we just need to be careful with our order of operations. What do you think I mean when I say evaluate this expression, this polynomial, for these values? Exactly. We just substitute. So wherever I have an x, I'm going to replace it with the number 3. So I have 2 times x, so that just means 2 times 3. Minus 3 times y squared, but y, we know, gets replaced with the number 4. Okay, so there we've done the substituting, and now we're going to do our arithmetic. So 2 times 3 is 6, minus, careful who goes first over here. Okay, so we'll square the 4 first to get to 16, times the 3 is 48. I just left the minus sign here, so 6 minus 48. You could have done it differently. So now I have 6 minus 48, which would be negative 42. Okay. So after we've evaluated, since I had values for each of the variables, my final answer is a number. Okay, so here's one of my challenge questions. And it's challenging because it doesn't feel like it has a lot of guidance. It's like, well, is this it? There's a lot of chance to second guess yourselves. So take a deep breath, be confident. We're going to write a trinomial, translate what that means. Degree 4 that has r for a variable, an odd leading coefficient, and a negative constant term. Oh my gosh, so trinomial, so 3 terms. Degree 4, the highest power of r has to be 4. Odd leading coefficient, so any odd number will do. How about 13? And a negative constant term, -4. So there's degree 4, variables are, odd leading coefficient, negative constant term. Now I need to get the trinomial part. So I need a third term in here with r's, and it can be anything. How about plus 2r, or plus 2r cubed, or minus 5r to the first? Anything like that would work. There are an infinite number of correct answers for that one. Okay, last little bit here. Let's go ahead and do some more practicing. I have 2 practice combine like terms, 1 practice evaluate. Go ahead and pause if you want. Give it a try. Meet me at the end. So 12x cubed. As I go through, I'm looking for other x cubes, and I'm just keeping track of how many. So 12x cubed plus x cubed, so 13x cubed. Now I'm going to go ahead and cross those off, like I said I would. Now I have negative 2x squared minus 6x squared. No more x squared, so minus 2 minus 6 is negative 8x squared. Cross those off because I've already taken care of those. And lastly, 9x, positive 9x, minus 8x. Remember, it's the sign in front that goes with the term. So it's a positive 9x. This minus sign went with the 6x squared. Okay, so it's done. So positive 9x minus 8x is positive x, or just plus x. Okay? All right, last one. Let's see. 8a minus 6a is 2a. Not an a. 2a minus 3a is negative a, or negative 1a if you want. And then 2t, that sign's gone, plus 15t would be plus 17t. You could write that 17t minus a if you wanted. Oh, one thing I mentioned before, I didn't actually check if I did it before. I said write in descending order. So on that first one, the 13x cubed, descending order means descending powers of x. So start with the highest one, and then write successively lower ones. So 13x cubed would go first, the x squared would go next, the x to the first goes after that, and if I had a constant term, it would go last. On the second example, all I have is a to the first and t to the first. There's no way to order those, so either way you would write those would be just fine. Okay, last thing, let's evaluate. 17x squared minus 3a. 4, x equals negative 1, and a equals negative 4. So it matters where it goes, right? The negative 1 goes in for the x, and the negative 4 goes in for the a. So 17 times negative 1 squared minus 3 times negative 4. And then it's order of operations. So I use these to make sure you guys have your order of operations down. So negative 1 squared is positive 1. That's the only part that gets squared. So then I have 17 times positive 1. And then I always think of this as negative 3 times negative 4 to get a positive 12. So maybe you thought of it as 3 times negative 4 first and got negative 12, but then you have minus negative 12. And that's where that positive 12 comes in. 29. Okay? All right. Good luck with your polynomial.